Ready? All right. So my name is Caspar van Leeuwen. I work at Surf, and I'll be giving this site presentation for Surf. We're both a long-time user of EasyBuild, and we're also involved in the Easy project. I'll cover both a little bit here. As I said, we're a long-time user. We started sort of back in 2016. When we compiled our module still by hand, we would actually use RPath wrappers to inject an RPath. So that's something that was, my predecessor said, okay, I'm happy to use EasyBuild, but I want RPath support first. And he also worked on that a little bit, he contributed, and once that was there, we started adopting EasyBuild at our site, with the first installation sort of mid-2017, and then from 2019 onwards, it's EasyBuild only. Initially, we tried to build everything for both the FOSS and the Intel tool change to have some kind of fallback option, like if one thing didn't work, at least we'd still have the other. But that proved to be so much work for relatively little benefit that with our new system, Snellius, we basically did FOSS only. So a little bit about our current system. It's a phased installation, meaning that every couple of years we get a couple more nodes. It's a general purpose HPC system. It's the national system for the Netherlands, so it needs to serve a wide variety of scientists. So we have both CPU and GPU nodes in there. And because it's a phased installation and because we have CPU and GPU nodes, it's kind of a mix of architecture. Right? So we have that's kind of our first challenge there, that we want to build for all of these architectures. Now, how do we do that? We basically have 4 prefixes for the 4 different types of architectures in there. And in those prefixes, we build the optimized software for that particular architecture. And then on the nodes themselves, we have a symlink that is node dependent. So on, let's say, Zen 2 nodes, it points to the Zen 2 prefix activity here. Actually, it's also the symlink that ends up in the module files. So if I load the GROMAX module on an interactive node, and I would do a with EUM'25, you see the symlink at the start there. If I then do a real path, you see it gets resolved to the Zen 2 architecture, which is the architecture of the login node. But if I then do an S-run and I submit it to one of our Genoa nodes, you see it resolves correctly to the AMD Zen 4 optimized GROMAX. Of course, we don't want to run EasyBuild by hand 4 times for every software package that we do, so we automated this. Basically, we use Jenkins to do semi-automated build. We have what we call a build list. This predates the whole easy stack concept. And basically, the only thing that this build list contains are the arguments that we pass to EasyBuild. Right? So it's a very simple thing. It loops over every line in this build list and just runs the ed command. And it does so for all of the 4 architectures. One thing that might be nice to point out, initially we also sometimes customized easy blocks and easy config, but we quickly found out that there was a bit of a pain to keep in sync with whatever happened upstream, right? You get some upstream changes, improvements, then you're out of sync, and unless you're very disciplined and you pull in those upstream changes into your own copies, it's easy to get out of sync and be lost. With the hooks-based approach, we can do the site customization that we want to do and have less issues with keeping in touch with upstream. So this is what our Jenkins view looks like. We just press a button, start, and it will loop through this whole build list. If there's nothing to do, it will be done in a couple of minutes, right? And it will actually farm out the builds to each of the architectures and do a native build on the batch nodes themselves. So this is a slide. I took it out a couple of days ago, and then yesterday I was on the new Ghent system, and I decided to put the slide back in because I saw that they did the exact same thing, so it must be a good idea. When you do an OS upgrade, especially a major one, so stuff in the software stack might break. So one of the things we did in the past was actually proactively build the complete software stack again on the new operating system. So we take a couple of nodes from the system, upgrade them, rebuild the software stack there. And then we would make sure that in the prefix we also have the version of the operating system in the prefix of the software installation. And that way we could have both software stacks next to each other, right? A RHEL 8 based and a RHEL 9 based, pretty much identical copies, but one built on top of a different version. And in that way we could even run like with a mixed cluster, so some nodes being on RHEL 9 and some nodes being on RHEL 8, and that worked. Actually, for the RHEL 9 upgrade, we didn't do it anymore. We ran a test suite beforehand. We didn't see any issues, so we figured, okay, we're good to go. Let's skip the effort this time around because it does take quite a bit of effort. If you built, something that you built 2 years ago, somehow something always breaks that used to work 2 years ago. So we figured this time around, let's see how far we get by not rebuilding. It went okay for the most part. There was some OpenSSL issues, but we could resolve them sort of on the fly. So that was also fine. For users, sometimes we don't want to install something centrally, like it's very specific, whatever they want, or they want, you know, a million versions of the same thing. Then we say, okay, we don't do that centrally. But we might help them write an EasyConfig file or update an EasyConfig file, give it to them, and then tell them to install it locally. And we have a wrapper to make that a little bit easier. It just set EasyBuild install path, EasyBuild optart, and here we set it to the lowest common denominator of sort of the architecture supported on our system, right? So that would be of the AVX2 CPU optimizations, and then it invokes the EB command. And this choice for the optart, it's kind of, you know, we know it's not optimal, but it's kind of a trade-off for like keeping things simple for the user. We also have a software policy just to do some expectation management for users, like what can they expect. We typically update our central software stack once per year. Typically, we just take the packages from last year and see if we can build new versions of them. We'll take the 2020 something A toolchain and try to release our software stack somewhere around Q3 or Q4. That's typically when you have, you know, the most common easy configs have been accepted, etc. And this software stack is of the order of about 400 packages. So it's, you know, a fair amount of effort, but it's doable. We're currently also considering to add at least the toolchains for the 2020 something B toolchains as well. For the more power users, they can actually use those to build their own stuff completely. We also do software installation requests. So if people ask, hey, I really need this or that package, we'll look at it, but we have a couple of conditions. It needs to be versioned. It needs to have had an official release in the last 2 years. And we're not going to do more than 2 versions in the central software stack per year. Now, this sounds very strict, and in practice, you know, we might deviate a little bit, but this is sort of the expectation we want to set. If there's a good reason to do something else, we'll do it. Yeah, we also have a part of that software policy is also a deprecation policy, and in order to make that very clear, like these yearly software stacks, we make them available through a meta module. So once you log into the system, the only thing you see are these meta modules. You load one of them, that basically sets your module path, and it makes available the module stack for that particular year. And it also confronts users with how old the stuff is that they're using, right? So if today they're still using the 2022 thing, we can tell them like, have you seen that there's quite a bit newer now? The last one, we basically say, okay, that's full support, right? If there are issues, we'll fix them. If you want additional installations, this is where we'll put them. From last year, we'll say, okay, there's limited support, we'll resolve issues, and like when we do this OS upgrade thing, we'll still make sure that this still works. But we're not going to put any new installations there. And then 3 years ago, that's deprecated. It's still there. If it works for you and you're too lazy to update, okay, that's fine, but you're on your own if it breaks, right? So we'll not fix anything there. We actually also still have the older stack, but we don't tell anybody. If you know where to look on the file system, you can still find them. That's mostly useful for us if we still want to dig into, like, hey, what did we do 5 years ago? So a little bit about the future. It was mentioned before, I think Kenneth mentioned it, like EasyBuild, it's super nice that you're able to share installation recipes because it allows you to share part of this installation, this software installation burden, right? But there's also limitations to it. Like we still, I guess everybody recognizes this. Somebody contributes an EasyConfig, you try it on your system, something breaks because you have a different OS or you have different configuration in your EasyBuild or, well, whatever. Something is different. So there's still limitations to how much we can help each other there. And I think Easy is kind of, to me, that's kind of the next evolution here. Like we cannot work on the same, like, not on the installation recipe, but on the actual installation itself, right? We can share the effort to create these actual installations as a community. So what we would like to do is use Easy as the base software stack. We already make it available, but we still have our local software stack next to it. But we want to use it as a basis, and then whatever is missing there and that we cannot push to Easy, we want to install locally. So we actually already have Easy as a main software stack on our experimental technologies platform. That's a very heterogeneous platform, so yeah, we're not going to build for every architecture there. It doesn't make any sense, and Easy facilitates this quite well. But also for our main system, for Snellius, yeah, if we then need to provide additional installations like proprietary stuff, we'll just use the Easy Extend module to install on top of Easy. Initially, probably we'll do that on the local file system because it's simple to do. But long term, we would like to create a setup similar to Easy. So distribute it through PVMS so that we can actually use it on all of our internal server systems, because we have a couple of clusters, we have a cloud environment, etc. And we'd really like to have the same software environment available everywhere. Also, this whole Jenkins thing, you know, it works, but it's not very nice, not very well maintained. Easy has a nice build bot, so that's something we would like to use as well. Yeah, there we are. By the way, there's a webinar about this type of usage. It's probably going to be on the 2nd of June, but we don't know exactly yet. If you're interested, you can follow the issue on the Easy support GitLab, and we'll pick a date at some point, make it definitive, and you can find it there. So advantages, I think, for this approach is that we can have more synergy, more shared effort with other HPC teams. Also, because of these phased installations, like every time there's a new phase being installed, we have to go through this build effort of building for the new architecture, right? We get a couple of nodes from the vendor, then we can do our build, and yeah, it just takes a lot of time. If we have Easy, there's a fair chance that somebody already made those builds available for that type of architecture. And if not, at least we can already try pushing it to Easy from, you know, whoever has that build architecture available. Again, it allows us to also provide a uniform software stack across all of our systems. I think that's convenient to our users. We'll have better build automation, and we'll get rid of this like optimization for users that we kind of now do in a lowest common denominator way. Easy Extend actually does that properly, right? It looks at your current hardware architecture, says like, okay, this is what I'm going to optimize for, and then we can just teach our users, okay, if you really need this on 2 different node types, you'll just have to do the installation twice. Of course, adopting some new technology always comes with risks as well, and that's something we're aware of. So one of the questions that easily comes to mind is like, how do you support a software environment where you haven't built everything yourself, right? It's just stuff pops up. For us, one of the mitigation strategies here is to be actively involved in Easy, so at least we know the inner workings of Easy and we know how that works. But we also think that the Easy community can provide part of that support, right? There's a lot of knowledge in that community, more than we could ever offer as a single site. Of course, there's always the risk with some project that it disappears. I mean, the same could happen to EasyBuild. Good thing that we have a very large community, so the chances are very small, right? For Easy, we're getting there, right? The community is growing, but we're not there yet. I think for us, part of the mitigation strategy is that if we have this similar setup with a local repository as well, even if Easy would disappear, we can quite easily rebuild the full software stack, including the compatibility layer, and just deploy the whole solution locally. Right? It's a relatively small step. Also, Easy provides infrastructure, right? There's the servers that basically provide the copies of the software stack. So the Stratum 0 has sort of the master copy, and the Stratum 1 is the one that serves to the client. We actually deployed a private Stratum 1 in our cluster. So basically, we have a full mirror of the software stack, and our clients talk to that Stratum 1 first. Only if that one goes down, we go to the public infrastructure. And the advantage is it makes us more resilient. Like, even if Easy disappears, we'll still have a copy of the software stack and we can continue running. We can't deploy anything new, right, in the Easy environment, but we can still continue running. And it also gives us better I/O performance because it's just very close in the network extent. Yeah, I'm almost there. I have one more slide. Easy. What if Easy doesn't support the hardware architecture that I care about? Well, so for that, we want to actually deploy the Easy Build bot on the server infrastructure so that we can actually contribute to building for Easy as well. And then this is my last slide. So you hear a lot about Easy, also in different talks. You might get worried, is there a feature for EasyBuild? I would say yes. EasyBuild is a key technology in Easy, facilitating both the builds in Easy itself, but also for end users. And actually, I think it might create additional adoption of EasyBuild, because I've had conversations with different communities in the Netherlands, for example, the geosciences and radio astronomy communities. They're very interested in Easy, like they're very interested in having an easy way to access their software, right? So we push some of the relevant software in there, they like it, and then they say, yeah, but now we want a different version. And then we teach them, okay, this is how you contribute to EasyBuild, how you write an Easy config, etc. That's how we kind of lure them into the EasyBuild space. That's it. Thank you.
Over to Bob. We have time for one short question. If it's on easy, I would wait until tomorrow because most of the morning tomorrow is actually focused on easy. But maybe if there's another question for Caspar. There's one online. What was the 8 to 9 approach? Then only rebuilt modules where problems were reported. Yeah, so
Yes, that's correct. So there were like 3 or 4 modules that we needed to rebuild, I think, to resolve the OpenSSL issue.
all right, cool. Thanks, Caspar. I will now get a very different view from the Netherlands, a university, rather than a central, what do you call service? Central service, central Dutch IT cooperative. Yeah, lots of words. Don't actually need that. Yeah. Keep going, keep going. No, this picks it up as well. Yeah, do it. Go ahead.
Can start right there. Yeah. Okay, I'm Bob Dröge from University of Groningen, also the Netherlands. Though we're from a local site, there's quite a lot of overlap actually with Caspar's presentation because we are also very active in Easy and have similar kind of plans. So I'm from the HPC team, mostly doing user support, training, software installations. I'm also an EasyBuild maintainer since a couple of years. Also active in the Euclid project, which I will show in a bit, and very active in the Easy and multi-xScale projects. A little bit about computing at the University of Groningen. So this is the Euclid project, which I'm also involved in. I'm the work package lead of the infrastructure for the Dutch data center of Euclid. We're collecting a lot of data. It's, I think, over 100 petabytes in the lifetime of the entire project. And part of that will be in our SDC. It's basically distributed across all the different SDCs, the scientific data centers, where the data is being processed. So this is all about dark energy and dark matter. I won't go into that right now, but there's some nice pictures which you might have seen in the media lately. LOFAR is a similar kind of project that we were involved in. I also did a little bit of work on that. We also have close collaboration with the hospital, where we maintain their clusters, and they basically run their clusters in our OpenStack environment as well. Well, we collect a list of all the publications that make use of our infrastructure, or at least we try to encourage users to acknowledge the use of these facilities so that we can maintain this list and show it to the university board to make sure that they see the value of these infrastructures. It says that we have more than 2,000 researchers on this list. We actually have quite a lot of accounts on our current cluster. I think about 200 or so are actually active. So we have like 200 active unique accounts per month, I guess. Well, a little bit of history. I don't have much time. I just wanted to show a few nice pictures. So we have a very long history in computing at University of Groningen. So this is actually the first device called Zebra, which is Dutch for basically very simple binary computing device with a staggering 500 flops. This is the entire list of stuff that we had. It's not complete, it has to be updated. This is on the university website. The most promising one in there is the Blue Gene, where we actually were in the, I think, position 6 in the top 500, which is, I think, quite nice for a small site. Our current cluster is way smaller, so doesn't really play a role in that list anymore. So our current cluster is named Habrok. That's from Norse mythology. Most of our infrastructure is named after birds, chosen by a colleague who's really into birds. This is running in OpenStack, actually, this cluster. We have 2 OpenStack clouds, one more focused on virtual machines, one more focused on bare metal machines. So Habrok is running in this Battler cloud. We also have a sort of innovation lab, bit similar to what Surf has as well, where we experiment with new stuff and have some collaborations with companies. And we were actually one of the founding parties of the Easy project. So some numbers, but I'll quickly go over them. This is our cluster where we have 4 different node types, 4 different GPU types. Well, we make use of quite a lot of open source products. Again, I won't go through all of those, but this is running in OpenStack, so we basically use Terraform and Ansible for setting this up as bare metal machines. So then a bit about EasyBuild. Also, when I started working at the university in 2011, most of the software installations were still done manually, manually writing module files for all the installations as well. Then my colleague Fokke Dijkstra, I think he learned about EasyBuild at supercomputing. He wasn't sure where anymore. I think it was at this user support tools meeting where I could at least found some reference to EasyBuild. And that was a great timing because we were just in the process of setting up our next cluster, and then we sort of came up with that policy to only use EasyBuild. We made some exceptions initially, but later on, mostly all the installations were done with EasyBuild. Quite soon, I think, we started using this build container approach. I think lots of sites are doing that now, but we already started quite soon with that and picked up a lot of issues because many easy configs were not really tested in a very minimal environment, so they were mostly picking up stuff from the host OS. By using this very minimal container, you could basically detect that and find that there were some explicit dependencies on packages that were usually installed on hosts, but in this build container they were not. One other policy that we initially had, but we soon let go of it, was that in order to keep it easier for our users, we wanted to try to stick to a single tool chain sort of per year. That means that we backported lots of stuff to that older tool chain, which also means that you have to backward all the dependencies, and that was quite a lot of effort to maintain all of that. So at some point we just let go of it and said, well, whatever is available in EasyBuild, we just install it regardless of the tool chain. So our current setup, it's Rocky 8, LMOD, EasyBuild. We store almost all the installations on CVMFS. We saw one sort of limitation with CVMFS. There's some way where you can enforce Unix groups on the CVMFS mount point. I think there's a way to get around that as a user by just remounting it in a container, for instance. So to be sure that this is not possible for licensed software, we still put licensed software that should only be available to a certain group of users. We store that on NFS, but that's just a handful of applications. All the other ones go onto CVMFS. We use EasyStack files to basically get a nice overview of what's available in our stack and to rebuild stuff if necessary. And we sort of took the easy approach, but we found it a little bit too early when we set this up a few years ago to go full in on Easy because, well, there was no production version of Easy available yet. So we found it a bit too risky, but we did adopt lots of the Easy build procedures by using CVMFS, using this build container, etc. Which is quite nice. Also, one thing in particular that I really like is this sort of transactional ingestion. So if you build something, we basically make a tarball, and then that entire tarball gets ingested into CVMFS. So there's just one moment where the entire installation either gets ingested or not. Also, if you need to rebuild something, the old installation can just be kept in place. You just rebuild a new one, and whenever that's done, you ingest the tarball, and it will be replaced in one go. So you're sort of sure that even if a job is running, there's no real moment where nothing is available. There's always one version available. So this is sort of our current infrastructure setup for CVMFS, where we have a Strand 0, Strand 1, some squid proxies, all with just a few cores. So for CVMFS, you don't need a lot of resources. That works really well. We haven't had a single issue, I think, since we have started using this a few years ago. And it works and scales way better than what we had before with an NFS share. So it looks like this. So we basically built 4 stacks for the different node types. We have a generic stack, which is not a generic build of all the modules, but that's a bit different from Easy. That's basically just stuff like MATLAB that we don't want to duplicate 4 times, even though CVMFS does deduplication, so it's not strictly necessary, but just for installing stuff, we found that a bit easier. So we have about 10K installations now. Well, again, sort of the build procedure is very similar to what Easy does. You can find all our scripts on our GitLab repo. Then the short-term plans, that's very similar to what Caspar just mentioned as well for Surf. So we're in the process of migrating our cluster from Rocky 8 to Rocky 9. Since we didn't use a compat layer like Easy does, all the software was built specifically for Rocky 8. Now what Caspar mentioned, that apparently it will probably still work on Rocky 9, but if you want to be sure, you probably should rebuild everything. But we find this a good moment to now completely switch over to Easy, because Easy is now mature. And then we build all the missing stuff or all the licensed software just on top of Easy with Easy Extend. We will use the EasyBot. Basically, we will be using the same approach that my colleague Pedro will be showing tomorrow for the dev.easy.io repository, which also builds on top of the production Easy repository. So if you want to know more details, that's your chance, or Caspar already mentioned that as well. The Easy webinar, which we will give soon, will also show an overview of how this will work. But in practice, this is what we will be doing. Basically, just also make Easy available on our Stratum 1 and still have our own Stratum 0 as well, where we can ingest our own software. So everything that gets built on top of Easy goes into our own local Stratum 0, and then the Stratum 1 basically just combines both repos, makes them all available to our current cluster. So final slide. So EasyBuild has made our life way easier, but sometimes that can be a drawback as well, because we usually install software packages quite quickly, but that raises the expectation of our users. Sometimes the user asks for like 5 installations. We do that within a day, and then after a week he comes back and say, oh, now I need these 10 packages as well. They're very important for my research, so please install them. One of the challenging things I have been experiencing, I think ever since we started with EasyBuild, is this toolchain concept. Lots of users find it hard to understand. In the beginning, that was even more so, because the toolchain was something like GoWolf-C, and no one understood what that means. It's a bit better now with FOSS and Intel, but still GF, BF, GOMP, and all that stuff. It's hard to tell users how to mix and match modules. I'm not sure how to solve that one though. And finally, I think that's partly solved now with the suggestion that someone made yesterday with this Python prefixes thing, but also building virtual environments on top of modules. We found a bit of an issue for users. I'm not sure if it solves everything, but we will definitely give that a try. And one thing that we see a lot, which will still be the same with Easy, I guess, but if you create a virtual environment, for instance, on a login node with a different architecture than your compute node, you might run into issues because the architecture is newer and you get illegal instructions kind of things. We also saw that with our installations, which partly solved by lowering the optimizations for those, but yeah, that's the thing, I guess, that you get with heterogeneous clusters. That was it. Hope I was on time.
Okay, thank you, Bob. Any questions for Bob? Can you go back one slide? I have an answer for 2 of these. So the toolchain concept, if you're doing hierarchical modules, you don't have to explain it to your users, at least not the toolchain names, but then you have to explain them what a compiler is. I'm not sure what's easier.
Yeah.
Yeah.
Sort of the same.
So that may still, so there's no perfect solution there. And maybe
I also thought about, I think someone even opened a pull request in the frameworks repo about this sort of generation naming scheme, where you basically just have the year that corresponds to all these tool chains, and then it's still sort of hierarchical, but
in the middle thing, that could actually help, yeah. So that's.
So you could just, instead of calling GCC core 13.3.0, call it GCC core 24.4a, for example.
Yeah. I guess that will be a bit more clear to users what all of that means, and stick to a single name, and then they don't have to worry about it anymore. But
maybe also in the context of Easy, we need to do some brainstorm session on that. So come up with a naming scheme that would actually be meaningful, or what only show the users what they care about, which is the software and the version, and everything else. We somehow get it out of view as much as we can.
Or offer different schemes that sites can choose between.
So I think one of the difficulties there is that it's true in the hierarchy as well, right? That you lose uniqueness. So at least with the default naming scheme, you have uniqueness. So whenever you consider these things like the generational thing, you have to deal with the fact that you will lose uniqueness when you take this approach. And that needs to be considered. And so I said it back then as well. I think like probably the best thing to do is to make sure you have uniqueness by always using the EasyBuild module naming scheme in one tree, and then develop a different tree that may not have that, and that's okay, right? Because EasyBuild will always build in the unique tree, so you know that you get the correct matching of dependencies and everything like that, and then only build the other tree as a user-facing interface.
Bart has a comment on it as well. But while I'm on my way, for the other thing, for the Python virtual environments and the R libraries, you should check our documentation in Ghent. We have some scripting around that may help.
Ah, okay. Ask you where to find it.
I mean, for Python and R, it's like what we do. It's of course with our wheels, it would be too hard to do with everyone. But to get back to the invisibility, like it goes back to my presentation yesterday that we basically flatten it to have the vast majority of modules we install is TCC core. And then there is some modules where you need to load like a compiler module. Well, this one loaded by default, but then because they're advanced modules like ACF5 and MPI based stuff, they're usually more advanced users as well. So it kind of sticks in when they just want R or Python or whatever, it's in the default level and they can just get it. So yeah.
Okay, thanks again, Bob. So 2 more short talks before we go to the social event. So Cintia was sort of dragged into this talk, I guess. You were dragged into this talk because you didn't say no, so.
Felt I couldn't say no.
Yeah, if Alan says you're good, you're good.
Okay, so my name is Cintia Willemyns. I was there at the last users meeting. So this is the site presentation for the VUB, so the Vrije Universiteit in Brussels, Belgium. So I will just give you an overview of our tier 2. And then I will just present the workflow that we use to manage software install requests. And I will present a script that we have that we use to software installations in our cluster. And there are a few nice tricks that I want to mention inside this script that we built in to make our lives easier and to solve some small issues that we have. So let me just go. Next slide. So the VUB is part of the VSC, the Vlaams Supercomputer Centrum, which includes also other universities in Belgium, such as the University of Ghent or the University of Antwerpen. So our cluster is a university cluster. The users are mainly students and researchers. And we have a HPC team there. So I work with Alex and Sam, that you very likely know because they're very famous in the community. I know. So the cluster we have, the main lines of the clusters is we use a Slurm scheduler. We have around 4,700 CPU cores. We have Intel and AMD CPUs. We also have NVIDIA GPUs and have a high memory node, Broadwell node. So as you can see, it's a quite heterogeneous setup. This is because we have to meet the needs of our very heterogeneous also. We use, as Alex mentioned, we have been using EasyBuild'25 for a few weeks now to all the installations for the toolchain in 2024A. So far, nothing has broken. That has been great. So that's the main an overview of our cluster. I'm gonna show a few parts of codes in the presentation. All of what I'm showing is in either one of these repos. So we have our own repo from our team, HPC, the HPC. We also have a branch inside the VSC software stack in a repo from the VSC. And I'll show a very quick thing that is in the EasyConfig body. Okay, so this is the workflow that we use. So when we get install requests, so if there is no EasyConfig for the software that we want to build, we will create an EasyConfig. If we need to create an EasyConfig from scratch, there's a PR that has been merged very recently with a bunch of templates, around a dozen of templates in different tool chains. That looks a bit like this. So it has just a template that is really nice to use if you're starting from scratch, an EasyConfig from scratch. So we can use that to have our to create the EasyConfig. Once the EasyConfig is it's ready, so we tested it locally. We will upload it to our repository, the VSC stack, software stack, to our branch, and we at the same time we create a PR in EasyBuilders. After that, we will install the software with our script, a submit script that I will talk about in the next slide. And finally, we have a small script that will clean our repository in the VSC, so the VSC software stack, once the PR has been merged in EasyBuilder, so we don't have the EasyConfigs twice in two different places. We keep our repo clean. So this is more or less the workflow. So now to dig in more into the script that we use, it's a Python script that is in our repo in build tools. So it will submit a job that will use EasyBuild to build and install software. And it will itself determine which CPU architecture where it will build, which architecture the partition has. Then it will create the Slurm job. We can use the option GPU to install GPU software, so it would only build in the GPU partition. And a very nice feature of this script is that it will also submit another job that depends on the first job that will update the LMOD cache. So that means that if the install was successful, then the cache will be updated right after. So that means that our users that are very impatient will have access to the module right away as soon as the installation is done. So that is a nice feature, I think. Of course, there are some options that we can use. We can change the build location. We have a bubble wrap to isolate the environment where the software is being built. We can choose in which partition we want to install. If we want to install only one partition and not the whole cluster, we have other options that we can pass EasyBuild options to. So the idea of the script is that it's very easy to use. Most of the times I only tell the script which EasyConfig to use, and that's it. But we want to keep it also flexible because some software need it. So this is an overview of what the script does, but it also has built in a few tricks to make our lives easier. Because sometimes there are some issues, and one of the issues might be that users are confused. So one of the very simple things for users that are a bit beginners is they use a GPU module in a GPU node, and the next day they log into a CPU partition, and they cannot find their module because it's a GPU module. So for this, we, with the script, we generate dummy modules for the CPU-only partitions. That means that when the user will look for the module, the GPU module on a CPU-only partition. They will find it, but when they try to load it, they will get a clear message of why they cannot load it, how they can load it, and there's a link also to our documentation. It's very clear what the problem is and how they can solve it. Another issue is maybe related to what Bob was mentioning just before, is that they get confused about the compatibilities and the tool chains and sub-tool chains. And for that, a nice, I would say, partial solution is to organize the modules by generation. And for that, we update with a script, we update the module class to based on the toolchain generation. So that means that when the user does module avail some software, it will be under either, for example, 2023A-all, and those are all the modules. It's a bit easier for them to see which generations the module belongs to. And it's also, I think, nice for us to keep our module tree organized and logically organized. So these are two issues that users get confused about. Very simple, but I think it actually really helps. Not only users can get confused, also compilers can get confused. And so we know that Intel compilers don't play really nicely with the ADM CPUs, especially when using options concerning involving our architecture options. So what we do is when building Intel-based software, we will tell explicitly what the -m-arch to use. For our Zen 2s, we use core-AVX2, and for our Zen 4s, we use Rocket Lake. So we know that that is safe and makes the builds more stable. Saves us some hassle. And the last trick that I wanted to show involves Java being confused. Java, it turns out that Java doesn't really take into account the memory allocated by a job in Slurm. It looks at the total memory, so that can very quickly lead into memory issues for users. So that's they will get memory. The users will get memory issues. This is not about the build itself. So what we can do is modify, so add a snippet in the Lua file, and to set that to change that the memory that is allocated by the memory that Java can use. The max it's a heap memory that causes trouble in this case. So what it does is that when you load the module, any Java module, what it will do is it will look at the actual memory allocated, and this snippet will make it that Java will take 80% of that memory and assign it to the heap memory. So that it's a quite a simple trick that users don't have to do anything, and it will work every time that the module will be loaded. So that's the tricks that I found more useful and maybe interesting for you to know about. There are other things also in our scripts that are nice, that may be useful. So that's it.
Thank you, Cintia. Any questions? Can you go back a couple of slides to the one where you use the or maybe abuse the module class trick. Yeah, this one is okay. Yeah, this one.
Okay.
I like abusing the module class for this. This is smart because these classes like bio and chem and whatever, I don't think many people really use them, and you're overruling that here to make it into something useful. So that's really nice. Can you go one slide further with the overview? I think one additional step you could take here is to remove the toolchain part of the module names. Like strip out GCC core, strip out Gompi, FOSS from the module name, and have a clean software/version module names. That would be way more user friendly, and I don't really see a big issue in doing that. I mean, modules would be shadowing each other. You may get the same version in multiple generations, and then but you will never be mixing modules, right? The ones that you really want will always be on top.
How do you call them?
But then the user would have to choose beforehand which generation to use. Because all of this is visible all the time. So whenever a user loads a module in our system, the module Elmod will look for all the generations. So they don't have to. It's not a hierarchical system.
No, but if they load something and they get the latest version, that's typically fine. It will be a newer compiler, but the software will be the same version. It will behave the same. So.
But how will Elmod know which one is the latest one if they have the same version?
It just loads the first one. It finds.
Okay, might work.
Maybe something to consider. It could be more user-friendly. All users care about the software and versions. They don't even know what a compiler or a FOSS is, or they probably don't have to care, right?
Yeah, it's something to try. Something to try.
So the issue with that Kenneth is that if you want to load other models together with that, then you want to be sure that you have the correct one with the correct toolchain.
Yeah, okay. So you load, let's say, what is it, BioPython 184, and then you load something from the 23A box, and then you're in trouble. That's what you're saying.
I do know how you could probably take care of that by sticking in a family in there. So if you stick a family 2023 into the module file, then you won't be allowed to load something else that's of the same family. Oh, that's true of any volume. You can have two. Yeah. You need something that keeps. Yeah, interesting. Yeah.
But one thing I think you could do is, as soon as you load the first module, you hide everything from another generation, and essentially make it unavailable. That would, I think, prevent that sort of.
Yeah, you collapse things. What we do in Antwerp or what we do in Lumi is simply first have a module where you select the generation.
Yeah.
But even then, you would still have, stripping the compiler, you still have problems if you also support Intel and have the same program installed with both Intel and GCC.
Yeah, non-uniqueness is always a problem.
Okay. It was just an idea. That slide triggered me.
Just to mention as well, because I have to contribute to it, in Elmod there's categories as well. So one of the things we have right now is we have this, whatever it's called, module class, right? But actually you could have way more flexibility, and you could have like a list of categories that something applies to, and then you can build lots of stuff around that, right? Because right now you can only put things in one space, so that's very restrictive, right? But actually you could do it if you maintained a table of categories, which you could update on the fly, like not have it in easy config at all. You can just inject that stuff like when the modules are built and rebuild, or even do it dynamically, right? You don't even have to have it in your module tree. You can have it as some table, a lookup table, right? And then things get classed according to that. And then you can build additional tooling to display only categories, right? So you can do a lot of stuff around that.
Okay, let's switch over to Helena. And just as a reminder, after Helena's talk, we'll go down, we'll have the group picture at the entrance of the building, and then we'll get organized to get to the karting center as well. So before you leave the room, and if you're joining us to the karting center, make sure your name is on the sheet so you know which car you'll be joining. Make sure you know who your driver is as well, right? So let's try and figure that out. Okay, let's go, Helena.
Okay, looks like we are a little bit cooked and we want to leave, so I promise it will be fast. My name is Helena, and today I will talk about, is it really easy? How much time EasyBuild saved us? But first of all, what happened to HPC now? we are rebranding, and now we are a business holding. So we have partners in New Zealand, Italy, Germany, and France. But we are the same people, and we do the exact same. We have consulting services with our clients to figure out their HPC needs. Then we install the hardware, the software, we give support, and we have an R&D service to figure of new technologies that could be interesting for them. The motivation for this talk was me in the office, installing something and sipping tea from my, thanks to EasyBuild, I have more time for coffee mug. Sure, a lot of you have it. And I was very frustrated and realizing that when I first started using EasyBuild, it took me a lot of time to get an installation done because of my inexperience with it. And now it gets me the same time or even more because my colleagues leave to me the big privilege to take the hardcore installations. And so, can you relate? Good. I'm not alone in this. The thing is, don't get me wrong, I love EasyBuild, and I'm not saying that just because I'm here, but it's true that the complexity of the installations has evolved a lot, and it went from straightforward kind of things to more complex installations. And that got me thinking, how much time are we actually saving as a community, and of course as a company, because we work by support our packages. So I started to snitch in my colleagues' work to figure this out, and I have some small data for you. So from all the installations we did in a 2 to 3 month period, only 6% worked or could be taken straight from the EasyConfig repo. I was expecting this number to be low, but at least 2 digits, But it's not that bad, because the 62% were existing but just needed some modification, and the rest, the third of installations had to be done from scratch. But better news are coming. So for the ones we had to do from scratch or to modify, 14% only needed a little upgrade. That means version upgrade, toolchain upgrade, some checksum adjustment, or both, all of them at the same time. And we are talking about 10 to 20 minutes, so all good. And luckily, most of the installations fall in the not much category. Here we are talking about 1 to 2 hours maximum. So again, not that bad. And this is maybe EasyBuild's fault, because we need to debug something, change some syntax, have to do tweaks for the site. But it's not that bad. And the ones that fall in the too long category, which is the 18%, here we are talking about days or even weeks, maybe even some months of work. But it's not EasyBuild's fault, because here we are talking about PyTorch from source, AlphaFold, all this kind of software. And when I saw in John's talk that these are actually the less loaded software in his site, I was heartbroken, for real. So good investment of our time, right? So okay, EasyBuild gave so much to us and made our life so much easier. What about giving back to EasyBuild? So our supervisors actually remind us constantly to contribute back to EasyBuild. So again, I was expecting a bit more of this 13% of the recipes that we created or that we modified to make it back to the repo. But not that bad, because on the framework side we did better. So I'm happy. From this 13%, half were modified and half were from scratch, split evenly. So I hope we're saving time to someone else. And funnily enough, now 85% of the recipes, we are taking them from PRs directly. So might want to work on merging all those PRs. A bit. Not pointing to anybody, just. And what about the rest? Why not contributing back to EasyBuild? Well, I interviewed my colleagues a bit, and I noticed a clear pattern between the ones that are in charge with smaller clients and the ones that we are in charge of the bigger ones. And turns out, for the smaller clients, most of them, they just have imposter syndrome. Like, they believe their recipe is not good enough to meet the quality standards of the EasyConfig repo, or that it won't be interesting to the community because it's super old software, that weird niche bioinfo package that they found in some paper of 11 years ago. Yeah, I can see people relating. And also, most of them were lazy to do the GitHub integration. That might be explaining why there's a decline in the from PR, new PR from the command line thing. And for the ones with bigger clients, we are talking about corporate world, super weird systems, and we just have to tune a lot of our recipes to fit that systems. And of course, they use very homogeneous abstracts with only one tool chain that needs to be very old, because if it works, why change it, right? And then obviously a lot of licensed software and a lot of recipes of somewhere developed by the institution itself. So nothing much to contribute there. I counted it, and from 40 recipes I did from scratch over the last year, I could only contribute back 2. But it's what it is. So if we have problems contributing back, and if we have problems with reproducibility, maybe we need to think about how we share software entirely. And of course, you've seen the talks before mine, and you know what I'm going to say. But there's already a solution, a very cool, nice project done by very cool people here in the room that ships scientific software straight to your machine, called Easy. So I also took the freedom to check for a random sample of 13 of our clients how much Easy already covered their software needs. And good news, for the ones with middle to tiny abstract, a steady 70 to 80% of the software was already covered. Good thing is that most of the missing software were packages that are already shipped within the Easy prefix. I'm talking Linutils, Flex, Bison, yada, yada, yada. So I filtered those. And the other big part of the missing software were Python packages specifically that were already included in some sort of bundle. I couldn't filter those, so I expect these coverages to be even higher. So good news, right? And the rest, obviously proprietary software, again, code development by the institution, so nothing much to do there, but not that bad. So imagine if instead of my colleagues and me installing the same software over and over and over and over and over and over and over, we just, right? And so we are all user support and system administration in the room, and we are all together in this. So this has been very elaborate propaganda for you to contribute to Easy. And finally, the first one, the tinier one, that it's only missing 4 modules. These 4 modules were Intel compilers, Intel MPI, Miniforge or some of the Conda family, and SPAC. So, so please, again, we are all together in this. If you open a PR to EasyBuild, you have half of the work done to contribute to Easy. So I expect to see your PRs soon. And also, I won't get technical. Tomorrow we have a full day of Easy. So with this cliffhanger, I have the privilege to send us to the social activity. Let the best one win.
Reminder, it's not an accident that the Do IT Now talk is right before the social event, because they're sponsoring it. So thanks to Do IT Now, we can all cart around for about 2 hours for free. So thanks a lot for that.